Today we're focusing on continuous variables again, and we're finding mainly three things: expected value, variance, and standard deviation. The expected outcome for discrete random variables, each outcome multiplied by its corresponding probability, summing all of those products together. Continuous variables, it's pretty similar, but it involves calculus. So the expected value, this time we've got the function. So you remember continuous variables, you can draw as a histogram. You guys remember this? And you can turn it into, if you make all the intervals really small, you can turn it into a graph, a function, and then to find the area under the curve, you integrate that. So that's what the integral is saying. The expected value is just, this time we're just like the discrete, multiplying each. So you're just adding an x factor. So say this function turns into x squared. What would be inside the integral before we integrate? X cubed. So the function of the area is x squared multiplied by x dx. So then you end up with x to the 4 over 4. It's a very simple example. Is there any questions about that? So that's the expected value. You would sub in, let's say we're going from 0 to 1. You would sub in 1 and 0. So your expected value would be a quarter. Variance. You possibly remember variance formula for discrete. Today we're focusing on continuous. So it's given by this function. So integrating again, subbing in the function, let's say it's x squared, but this time you multiply by x minus, what does this value represent? Expected value or the mean? The standard deviation, just like discrete, is the square root of that variation. So you find the variation, do the square root, just like we've done in the past for discrete. Yeah. Median is a bit different. If you forgot from year 9 maths, median is the halfway point in the data set. When we have continuous random variable, this is, I don't know if you remember, you can't find an exact value in continuous random variable. You do it to 0.5, and that's how you figure out the median. Does anyone want me to show you on the TI? Sound surprised?
I'm surprised.
So yes, nsolve. I don't know if you remember, I was talking about the function that I was saying was x squared. So if we want to find the median of x squared, you use nsolve like on the screen to find that a value. And that's where the median lies at a equals 1.14471.